Okay, guys. So please, where did I stop before the the unforeseen happened? Hello, guys.
Before we ran script, I don't think you finished typing before the thing went off.
Okay, I was typing the script, right? Okay.
I think so, yeah.
So, let me start over from the top. Remember, we actually wanted to we are following a task that we want the script to execute. Okay. So, not this. The script is meant to do this. That is to ask the user, excuse me, to ask the user to enter their full name, and we use the echo command to do that because the echo command outputs information to the screen. Okay, single line of text. Now, after that, excuse me, after that, we need to have an avenue that the user must what must input, because we have actually put a command here. If we are asking the user to do something, so there must be an avenue for the user to do it. So that is the function of the read command. The read command gives a prompt where the user can enter, okay, values. So the user, we use the read command to collect input from the user, and then the input that the user enters is stored into the name variable. Now onto the next step, said ask the user to enter their year of birth, which we use the echo to do that here again. And then what we use the read command to initiate the prompt that the user should enter their year. So whatever the user enters, it is stored inside this year variable. So now we want to do something that we want to calculate the age of that user. And by that, in that sense, we are creating a variable called present, which is storing 2023 because we are currently in 2023. So we want to perform something like a logic whereby present we what we subtract the users here, or whatever the user entered will be subtracted from what present, that is 2023 minus the year that the user entered. And I was explaining something about arithmetic operation in shell, whereby probably I was using this example that okay, let's say we want to add two number, and let's say this the result will be stored inside this variable called result. Okay, so now in shell, whenever you are performing arithmetic operation or general arithmetic operations, it is, you must start with a dollar sign and then enclose it inside parentheses, or square or brackets, you understand? So so we must start with a dollar sign, and then inside the parentheses or the brackets, then you have the computation. You understand? So so you have it this way. So this dollar sign and the computation. That's why we have results, and then we have the dollar sign, which is to perform what this computation a plus b, adding two numbers. Another thing we have, it was a typical example where we have this constant 2 plus 2 inside the parentheses, and it will give us this value, which is 4. And we can do every other thing, every other arithmetic operation that we have. Of course, we know the law of arithmetic, the Bodmas operation, the Bodmas rule. The Bodmas rule, brackets will be solved first before every other thing happens. So, in fact, we can still have something like, if we have these two results performed, they should be, we can have even something like times 5. So it will be like this set, this one will be operated, and then it will happen to this, and then it will go like this. So we all understand. So what we need to understand is the dollar sign and the computation inside what parentheses. So the same thing is the logic we are trying to what implement here, where we have the age variable, and the age variable will be computed with the present what minusing the what the year that the user imputed. And then now we are storing the value. We want to actually print, from here. After we have gotten the age of the user, we want to print to the we want to print today's date on the screen. There is also another operator in shell called the date operator, whereby we can automatically get today's date today's date from the shell. We can get today's time from the shell, you know. So we can get today's year from the shell, and this is done with the date command. So the date command has it. So in order to actually access that, we we use the dollar sign and then impute the date command inside the parentheses. So that will what supply date. So if you are printing today's date, so it is just like this. So if I do echo on the screen, if I echo like this will print today's output full date. Let me call it that way. So it output full date, the date, the year, the time, everything. So we can either do it this way, or we can do it this way too. Backtick dates. This works too. So that's just how to get today's date. But mostly this is the modern way. This is like the old way, and it's actually going extinct into extinction. So this is actually the modern way of actually running the script. So whatever when we get it, we are storing into today. So the next thing is now to output all of these function, all of this command, finally print to the screen. No, okay. So it will now print. We are now printing "You are welcome," referencing the name that the user entered from this line. It will ask for the name already here, and then the user will input the name. Now we are referencing whatever input on the name. This is the name variable. Obviously, we said from here, the read command can collect input from the user. But when we don't specify the variable, it should what store it. It will just collect, and it will not be stored anywhere. But with this like this, it is the input from this read is stored inside the name. So this is why we are referencing it here. The name, the name that the user entered, we will reference there. And now the next one is so you are age. The age here will be what? The age that was computed from this line. Okay. So the age that was computed from this line will be stored into the age variable. And the age was computed from the present minusing what? The year that the user entered. Now we now say we are echoing what today is today by what? Collecting the value of the date from the date command, and which is stored inside the today variable. Okay. So if I should save this and run this script, we should have our output as expected. Now I can run my script in three different ways. I can add execute permission, to the file. I can add execute permission.
Hello, my hello.
Yeah. Hello.
Can you zoom in? I'm using my phone. It's a little bit small.
Okay, sorry about that. Come please. Why this one is sorry, no. Come. Okay. Um this Ubuntu focal virtual this thing. So let me take my mouse in a minute. Currently, permit me, let's continue this way. I don't know if you can just manage because um I don't want to waste time on this, and my mouse is even far. I
No
can't even
problem.
find it.
No
So
problem. No problem.
yes,
Thank you.
so we can. I'm trying to explain something that how can I ways I can ways I can run the script. I can run the script by adding execute permission. Okay, let me do this. Probably this will should work. This side. So I can run the script by adding execute permission. I can do that. I can also run the script by adding it to the shell environment, and I can lastly I can run it by using bash script name. So these are three different ways I can run the script. So I think I have not run scripts using bash before. So let's say this is the list of files, and I can do bash. Um, what's the name of our script? Greet user. Remember, look at this. We've not even turned it to an executable, but it will run and it will what? It will perform the action or instruction inside. So if you run our script, look at it. Please enter your full name. And if I say Michael Bamidele, now it's giving me the next prompt. Please enter your year of birth. Now if I input, can you see? You are welcome, Michael Bamidele. So you are 26 years old. Today is Friday, July 7th. Time 22:12 UTC, even my time zone, and then 2023. The script has performed what we asked it to do. So I can, if I clear, I can turn it to an executable, you know, nonsense. Yes. And I can always run it in this way, and it will do the same thing. And I can just please enter your year of birth 2000. Look at, you are welcome, Michael Jackson. So you are 23 years old. So it's a look at, you can see this computation. You can see how dynamic it is. It is what? It is computing the age by what? By the user input and calculating, performing operation on it. Instead of imputing or type coding, and even the date too. Today is the date too is what? Dynamic by the date command. If I run the date command here, like I was saying, if I do echo, if I do backtick dates, can you see? It gave me the date. Or I do echo this one, can you see it? So I think lot of things has been established here. We've been able to um, learn about the read command. We've been able to learn about variables in shell, and we've been able to learn about arithmetic computation, and we've been able to learn how to what? Set values to create variables and set values to variable, and we've been able to reference what? Variables even in echo commands or echo, yes, the echo command. So I think I've been able to do some justice. Do we have question, clarification? or probably some kind of possibilities to it can come in. Yep. Now, if you look at this, I have some scripts here which I created. I created something. This one asks for full name. This one asks for account login. If I, they are actually this basic that I have spoken about. You know, they do all this basic. We have this read command, and then this read command. For every shell command, there will always be flag based on the command, and that flag will what perform different options. Now, this read command here, read with this p here, it gives option of it gives option of prompts at the same time. Instead of me using echo, it eliminates echo. I don't want I'm not going to be doing write echo on a line first then coming to read. Instead, I can use the read command to perform the work of the echo and also store the value into a variable. That is where we have the read command, and with the flag p, it will prompt the user and at the same time store whatever the user enters into what into the variable, this variable username. And look at this next line, say your username will be, and then referencing the username variable. Now we now have another one again, read. Now this flag s called silent, and this p for prompting at the same time storing the value. So for prompting, it said, please enter the password you like to use. And then the user what can enter the password and it will be stored into the password variable. And at the long run, we can now echo a space, and then we can now echo you entered, reference the password for your password as your password instead. You know. So let me run the script and let's see what it does. If I do bash account, what is your desired username? Your username will be overtyped. Reference this line. Please enter the password you like to use. So if I start entering my password, you can't see anything on the screen. Okay, I entered 1 2 3 4 5 actually. And you see you entered 1 2 3 4 5 for your password. It is based on the string here. This line is running. So I now say masking what what is entered does not obscure the data. This is just a line from this text. So what do we learn here? Basically, the read command can have flag. If we do man read, we can see read from a file descriptor, and we can see read attempts to read up to count. Okay, and just all the documentation that we can see from here. Let me go to the flag. Okay, the flags are not the flags are not referenced in this manner. If we read on the documentation online, we see that. So we've able to learn about variables. So now let us talk about piping in shell, and after that we call it a day. So now pipe command in Linux. So the basic concept of the pipe command, you know, I'm coming. Let me open this. Let me open this resource so that we can be able to understand something. Okay. Let me look for the 5 meter size. 5 lines. Okay. Now, as we're talking about pipe the other time, there's what we call pipe in Shell, and it's under like filters where you can actually collect inputs. You can actually turn an output into an input. Okay, so what we call about the pipe command, the basic concept of the pipe command is that the pipe command collects the output of one command operation, and then it serves as an input for another command operation. So the concept is that output of one command operation serves as input for another command operation. So this will be a command, like for example, we have cat, a file, and then we have the pipe symbol, and then another command will what performed on it. For example, if we should have let's say this school file cat school, what this cat is to do actually to output the content of school to the screen, right? That's what it's to do. Now if we now do cat school, and then I pipe using this symbol, I'm piping what, instead of it to output the to give me the output to the screen, it is going to send it like an input. Okay, but I'm using pipe. It's going to send it when this pipe operator appears. It's going to pipe it into this less command. So the less command, it will take the output from here and then perform less on it. Okay, so it will now look as if I'm writing less school indirectly. So if I run this now, you can see, as we know that the less command is for what, for reading files or for displaying files in a paginated form, like as if it is in pages. You can see the content of the school has been what, has been opened, and we haven't end here. So to always go out of the list file, we use the queue. So the concept of the pipe is to, you can pipe as many commands as possible. And let's say let's say we want to echo, we want to echo hello. Now basically hello will be what, displayed to the screen, but we don't want it to do like that. Instead we are piping it into that it should do, what should you do on the hello this thing. We should take it, what can we do? We can do word count, word. So we are piping the output of the hello command, and then we are running the word count operation on it. So it will count what the words from this echo. Of course, this is just one word, and what we should receive is one if I run it. So you can see the output is what one. And if I cut school and I pipe it with word count, of course it will give me the number of words there, and we have what, 9 words. And I can even cut school and print the number of line there. Probably I want to count the words and the line too. So it will give me 2 line, 9 words using what, the pipe command. We can do as many possible operation that is with that is possible. So looking at this is a pipeline, the capability of commands to read data from standard input and send to standard output. Hello guys, are we still there? Let me see. Okay.
Yes, yes.
So collecting from standard input and then sending it to another standard input. That is what the pipe does. So using the pipe operator, the standard output of one command can be piped into the standard input of another. You can see. Look at this. This is to list what? To give a long listing of the content of bin, which is inside the user directory. So now, instead of outputting to this, it is now sending it into the less command, and it will what? Output it like a what? Like a document. Let us do something. When we do a long listing of this directory, this current directory that we have, this will give us this. So we don't want the output to come like this. We obviously can say long list and pipe it into less. Can you see? So it's as open like a document. Now we can now add lots of um command together. We can concatenate, that is join different command. For example, I can do less long list pipe it into less, and then I can say redirect it, instead of it to even project it, redirect it into this directory dot text. If I let less and I cut this directory dot text, we will have this. Even though this does not make sense, like I can practically do long list and then you know if this doesn't make sense, I can practically do long list and then redirect it into this directory.txt. But what matter most is that ability to pipe different command into commands. It is very useful, especially when you are trying to create um a logic, or you're trying to even create probably an algorithm, or you're trying to solve something you know so that is that. This now let's go on to see some of the power we can apply. So this is extremely handy. Using this technique, we can conveniently examine the output of any command that produces standard. Now there's something. Now we can use this command. We have sort, we have unique, we have edge. For example, a project is coming here. We can say let's list. We can say from this school file, if I cut school, let's see what is inside. We can actually specify that it should display only the uh first 10 word or first 10 character on the first line. Let us take a look at this command called add, man add. Look at set add actually outputs the first part of file. It can print the first 10 lines of each file or as many. So now we have the flags. It can print the first number bytes of each line. It can print the first line with number lines, okay? It can print the first n lines, okay? Probably first 5 lines and so on like that. It can print q, we have all of this like that. So let's say we want to print just, we have another one called man tail. It output the last part of file, okay? So let's say we want to output the last part of a particular file, so we can do cats school. Of course it will print school, but we want to pipe it into this tail, and then it should print what? Only the last part. But to use this tail command, let's see. um Look at output the, if we want to output a particular line, output the last number n lines instead of last 10, or use, okay, let's even just run, let's run cat school and then pipe it into tail. It actually outputted everything. But let's say cat school, the last tail, let's say second line. Okay, I'm not using that. So cat school till n 2, the last two line. Let's say cat school till the last line. Can you see? I'm trying to introduce this concept to see all these possibilities, so that, of course, we are just playing around the shell. We have not, we can actually devise a particular thing to do, but these are possibilities. We have the head, we have the tail, and we cannot use, you can use the head, the tail, the less command, and so on, or sort unique and all of that. You can use all of this command in conjunction together to perform an operation using the pipe. Let's say we want to search through, let's say cat school. We want to search through this school file, okay, and we want to look for every string or every text that has data in it. How many data do we have? We have data, we have just one, two. So we want to highlight or search for every of the string data. There's an handy tool that can do that, and it's called the grep, or grep. Okay, so let's come to that. The grep command. This command is used for searching files based on a particular pattern. So we can search for files in the shell based on a particular pattern. Now, there is something I want to open. This global search regular expression print. Now, if we have this, how does it work? Um, Let me just use an example. Let's say we want to search for the character data inside the school file. So what will this do? This will search for every word that has this pattern DATA inside this file, and it will highlight them. You can see it has what highlight them on every of the line. When we study the if you read the manual of the GRE paper, this thing, we can see how many flags and a lot of things that can be used in it, trying to search for as many things as possible. But what matters most is that we understand these possibilities. For example, I can see cat school. I'm piping it into grep, and it should what? It should search for every match of data inside the school, and then instead of it inside, okay, I don't even need to specify the school. So I'm sending in the output of this man into this file, and then send the output to this command. Let it search for. Yeah. Now we can now even do something that we can pipe it that it should now what? It should um what can we do? We can now redirect it into data.txt. If I can, okay, this actually redirected everything. But let's see. Data. Can you see? So we can be coming from a command and then initiate what? This operation on it. Now let's do something. Let's say I create a file called phone book. Okay, let me call it cards phone.txt. So I'm having different patterns of number 081, 081, 2, 23. That's one pattern. I have another one 080 with space 123, then 518 11. Right? Yeah, correct. 123 518. Is another pattern 081. Okay, so cat phone. Now we can have as many phone number, but what we are looking for, let's say um we are looking for this very one, which is 081 081 2351 8119 in this pattern without space, without all of this format. We are only looking for this format. This is possible using the grep um, command. But now, when we use the grep command, there are different filters. We call it filters that can be used alongside in order to search the pattern, in order to search to make a streamlined search. For example, there is a symbol here, there is an image here. Look at this. We call it the regex this thing. And this is how it works. Where you have this raised to power symbol, where it should start, the start of the line. Then you have the square brackets talking about the range of numbers it should look for. That is, it should look for from A to Z, having probably hyphen or letters or underscore. As long as it sees this pattern, this match inside this square bracket, it should what? It should return it. Okay. And we also have this range of characters that must be present, which is this brace. The square brackets indicates the kind of possible characters it should what search for and return. The square bracket. The brace talking about the range of characters, probably from 17 to 19. The numbers from 17 to 19, or from 0 to 9, or from A to Z. And this one talks about the end of the line. Now, obviously, when we run this, if we are trying to do like, okay, let me just type all of this, trying to do this, and let's say 0 within the range of, let me just put what is here, A to Z is 0 to 9. I'm coming, I'm trying to drive at something. Underscore hyphen, and we have raise 7 19 close brace dollar sign. If I copy all of this and then if I do like this on the terminal, there is no way. If we run this and trying to look for this, let's say we are now trying to look for it inside phone.txt, this will throw it will throw an error, because all of these characters are special characters and they will be interpreted into different things as far as this shell is concerned. So basically, we need to understand, if we're trying to make a search using the grep command, then we must actually, of course, understand the possible pattern for search using the symbols that are available. But we cannot just run those symbols directly to the command line. It will throw an error. We, of course, need to find a way to escape all of this so that the shell will not see them as special characters, but will see them as a regular text. So if I run this now, you can see unmatched. It cannot even see any of this. So it is seeing it as what? As separate entities. Now there is an example here. We are trying to look for the content of this file phone.txt and look at all the contents, different possibilities. Now imagine that imagine how they run the command here. If you look at this, a lot of escape characters was what was used to preserve the format of this thing. If I zoom in, you are trying to search this from phone.txt and to search for probably just this number, to outline this number, or to highlight only this number in a text file, or to highlight any of this, or probably every of them that has this phone number in whatever pattern. Probably you are trying to search inside a big text, a big document, and you're trying to search for a particular pattern of word. While I was on, what are they calling it? I was on this my PDF document. I was trying to search for pipeline. So in this document now, every entry that has to do with pipeline, this find command, this search command, what will return it for me. So that is just like the basic work of the grep command. So it's trying to search for every matching character, every matching word. Okay. So now we talked about the the uh, the acceptable string for the grep command, which is all of this. And this is talking about from the start. You should start the search from the start of the line, then look for any of this character as long as it can see any of this character. Then this is within the range, the brace, and then end of the line. So if we run this will be treated as special characters individually, but we need to use escape character or escape form to prevent shell from interpreting all of these symbols. So that was what we were trying to do here. You can see how long the text is when they did something like this here. It is trying to tell you that this bracket, it should what? It should treat it as a normal bracket, and then it should look through this. You can see it should look through this from 0 to 9. Okay, it should escape braces and treat it as a normal entity, and also forward brace and the last brace, and then it should look for range of 3. That is, it's trying to look for 0 from 0 to 9 in 3 different ways. The explanation is here. Let's see. Look at this. The logic of the entire area code section is trying. You can see that, okay, when you use square brackets, you are letting grep know that you are looking for a number between 0 and 9. Similarly, you can use A to Z, okay, in order to match letters of the alphabet. Okay, so the number in curly brackets, like these three, it means that the item in the square bracket is matched exactly 3 times. That is, the items in the curly bracket is matched exactly 3 times, which is, look at this. This the item is matched exactly 3 times. Okay, now, okay, so it's saying look into brackets and look for numbers from 0 to 9 inside square brackets and match them exactly 3 times. Okay, now the same thing as seen here. Now, sometimes this looks complicated because you'll be like you'll be trying to look at it that why are you trying to match exactly three times? Because the content of this phone book is 1 2 3 4, and if you count 0 1 2 3, so you're trying to make sure that the search run through the first line, the second line, and the third line. So but it will start its count from 0 1 2 3. So but what matters most here is that with trying to study um the grp command, you can try to search for different matches of characters. Now let's try what we can do with our own code here. We have grep and we are trying to search for, now this is 0 1 2. We might not even try to look for that, but let's say we are trying to um search for, okay, we don't have anything like open brackets, so we can escape that, but we can say search for from 0 to 9 within this range. Okay, and what can we do again? We can say match this, let this match happen, okay, two times, 0 1 2, two times the closing brace, and then we can still tell it to search for inside the pattern from zero. Now, okay, zero from, look for zero, any number from 0 to 9. Okay, then we are trying to look for space also, so we can say look for comma, look for space and look for comma, single space, and then comma. Okay, we are referencing all of this. And what again? I think these are just all of the possible um entries here. We have square brackets. We are trying to tell it to um omit the square brackets, and then from 0 to 9, look for number from 0 to 9, look for space, and then hyphen. Then we are trying to tell it to look for this range, let the search appear two times. In this case it will be 3 0 1 2 3 and 0 1 2. So can let me cross check something. Okay, obviously we are not even looking for, okay, there might not be need, for this, because all we need is the square bracket and search for all of this. Then we might need that for the brace. And what were we trying to look for? Inside phone.txt. I think so. Let us see. Okay. Can we see our results? Let me see. Are people still following? Okay, people have gone offline. Okay, I think I will just do the rest and then the session. So when we run this is what we have. Okay. So obviously 9 is being omitted from 0 to 9. Okay. Can we see why 9 is being omitted? Okay. We we need to see why 9 is being omitted. Can we fix that? Let's see from this reference. Okay. Can we do okay? So there's a reason why the 9 is not part of it. Probably we have to escape space. Okay. Probably we have to escape this. So obviously just this way. But what matters most is to get the basic idea of this grep command. Okay. So guys, I think we are able to gain some little idea. We can use the grep to get matching characters or pattern in a file. So let's see if we can use it on school. So let's say grep and school. No, you are trying to search for this character, any of this character. Mhm. You know, we are trying to search for space, and we are trying to. So we can specify how long this should apply. So let's say one time, and we are applying it on this profile. Okay, the range is invalid. EC2. Okay, since there are no number, let's say A to Z. Okay, let's take away the range. Okay, probably this will be okay. We are trying to search for any of these characters, so we have to do an escape to search for this. Okay, so it couldn't find. Okay, let's see if we can look for 0 to 9, and it couldn't find it. Let's take a look at this. Okay, Okay, it was the space in between. So we can do A to Z, and when we return this, and we can do capital A to Z, you can see it's covering all of the possible values. Okay, guys. So I think we've been able to learn something here, and we'll call it a day from here. Thank you for tuning in. Thank you for joining. See you next time. Okay, guys.